We are going to start today with solving by grouping. We're going to solve these quadratics and stuff a little different than we have been. And this is, a lot of you look at a cube and you go, oh my God, I got to factor this thing. This is so hard. No, it's not. What we're going to do is we're going to look at this and go, okay, we're going to solve this by grouping. Let's try that first. So when I group things, I got to take that negative sign with me. I have to. Now I'm going to take out what I can out of the first one to make a match. So I can take out an x squared. And I have 3x minus 16 left. Out of the second one, I can take out a negative 4. Okay? And that gives me 3x minus 16. Well, if you look at it and you remember how to GCF factor, this is exactly the same as this. So I'm going to take it out of both of them. I'm going to have 3x minus 16 times, what's left over? X squared minus 4 is all equal to 0. Well, what I'm going to do now is I'm going to take those things and I'm going to set them both equal to 0. So I'm going to have 3x minus 16 equals 0. And then I'm going to have x squared minus 4 equals 0. Well, here I add 16, divide by 3. There we go. Then over here, I can either factor it, or I can just say x squared is equal to 4. Take the square root of both sides. Now, on your last quiz, some of you forgot when you take the square root, it's positive and negative. So I get x equals positive or negative 2. So what my roots to this thing are is 16 thirds, negative 2, and 2. And that just took a hard-looking problem and made it look really easy. That's the first type we're going to do. The second type is we're going to solve them when they're in quadratic form. Okay, when you look at this thing, you're going to have 2x to the 4th is equal to negative 7x squared plus 15. Well, get it all equal to 0. So move everything over. 2x to the 4th plus 7x squared minus 15 is equal to 0. The only problem with this is you're to the 4th now. You don't want to mess with that. So what we're going to do is we're going to go over here and we're going to go, okay, let's play a new game. We're going to let y equal x squared. So wherever there's an x squared, start here. That's 7y now, minus 15 equals 0. And then the front, it's 2y squared. And now it's in a form we can solve it pretty easily. I'm not going to try and mess around and factor this thing. It doesn't look fun to me. So what I'm going to do is use the quadratic formula. I'm going to say y is going to be equal to negative 7 plus or minus the square root of 7 squared minus 4 times 2 times 15 all over 2 times 2. Okay, so if I do that, I get negative 7 plus or minus the square root of 49 plus 120 all over 4, which will give me negative 7 plus or minus the square root of 169 over 4. If I move over here, that gives me negative 7 plus or minus the square root of 169 is 13 all over 4. Okay? So that's going to give me, if I put it in here, I go, okay, negative 7 plus 13 over 4, or negative 7 minus 13 over 4. Well, negative 7 plus 13 is what? Very easy. That's 6. So I have 6 over 4, which is 3/2. Or negative 20 over 4, which is negative 5. Well, here's the problem. This is what y equals. We don't want what y equals. What we do want is what x equals. So now I got to take both of these and go, okay, x squared is equal to 3 over 2. Or x squared is equal to negative 5. Take the square root of both sides. X is equal to positive or negative square root of 3 over the square root of 2. Well, I can't have a square root on bottom. So I multiply both square root of 2, square root of 2. So I get x squared is equal to positive or negative square root of 6 over 2. Not x squared, that's x. I'm sorry. I screwed that up. There, x is equal to that. Now I look at the other one. Okay, take the square root of both sides of this one. X is going to be equal to the square root of negative 5, positive or negative. Well, the square root of negative 5 is x equals I, positive or negative, I times the square root of 5. So I have my 4 roots. X is equal to the square root of 6 over 2, negative square root of 6 over 2. Well, my 2's are kind of messy here. I square roots of 5, or negative I square roots of 5. And there are my 4 roots on this one. Now, we're going to look at something else called the rational root theorem. And this is actually going to make it a lot easier, believe it or not. The first thing you need to know on the rational root theorem is you're going to list, this is a rational, root theorem. You're going to list all factors of your constant term. And we're going to call that P. Those are P. Then you're going to list all the factors of your leading coefficient. And we're going to call that Q. All of your possible roots that could happen, anything that's possible. So all possible roots are going to be x is equal to P over Q. Sounds a little confusing right now. Wait till we do the example. You'll see it. It's not hard. It actually makes this kind of easy. So if I have 3x cubed minus 4x squared minus 5x plus 2 is equal to 0. The first thing we're going to do is find all of the factors of the constant term, which is right there. And that's what we're going to call P. Well, 1 times 2 is 2, right? But you got to remember, it's positive or negative 1 or positive or negative 2. Okay, then we're going to look at the leading coefficient, and that's Q, and all of the possible factors of it, positive or negative 1 and positive or negative 3. So now what we're going to do is go over here and list all of our possible roots. Well, take 1 and put it over 1. So there's 1. 1 over negative 1 is negative 1. Then you go 2 over 1. Negative 2 over 1. 1 over 3. 1 over negative 3, or negative 1 over 3. 2 over 3. And negative 2 over 3. All of those are possible roots for us to do. What we're going to do now is start trying these roots to see if they work. The first one, try 1. And we're going to synthetically do it. Makes our life easier. So we go 3, negative 4, negative 5, and 2. Remember, the rational root theorem says if we end up with 0 here, then it's a root. So we start off. We go, okay, 1, bring down to 3. 1 times 3 is 3. That gives me negative 1, negative 1, negative 6, negative 6, negative 4. That is not a root. Okay? So now, okay, let's try another one. Let's try negative 1. And you can go negative 1, go into 3, negative 4, negative 5, and 2. So I bring down to 3. Now I got negative 3. That gives me negative 7. Well, that gives me a positive 7, which is 2, negative 2, 0. Hey, I got my first root. That one works. From here, I can continue on and keep trying all these roots until I get down to where there's only one, you know, I know I have to have 3 roots, okay? But what I'm going to do now is I'm going to factor this, okay? So I'm going to say this is 3x squared minus 7x plus 2 equals 0. If I factor this thing, I'm going to get 3x minus 1. Gosh dang, that's ugly. Sorry about that. 3x minus 1 times x minus 2. Well, if I solve this, I'm going to get x is equal to 1/3. And I can check. Hey, that's a possible root. We're good to go. And here I get x equals 2. Hey, it works too. So now I know that my roots are negative 1, 1/3, and 2. And that's the answer to the problem. That is how you use the rational root theorem. All right? I hope you get that one. And we will hit the next one